Lesson 2.4, Algebraic Reasoning. Essential question: how can algebraic properties help you solve an equation? So let's go to what we did last year in algebra. We're going to solve an algebra problem, and we're going to list all the reasons. And these are the kinds of things we're going to do in this course. When we do steps, we're going to have reasons for why we do them. So here's the problem, and it was given to us, so really the justification that it was given. I want you to notice that there is no parentheses there, and the parentheses is gone, and that's because we use the distributive property. Okay, on the next step, it looks like we just simplified and made that a 1. So the reason we can write that step is simplify. On the next step, it looks like we are subtracting the same thing on both sides. So this is called the subtraction property of equality. And then it looks like we're simplifying. So then this is simplify. The reason we have that line is simplify. Next step, it looks like we're subtracting again on both sides. Subtraction property of equality. And again, we simplify. The next step looks like we are dividing both sides, division, property of equality, and then we go ahead and simplify. And when we turn it around, that's called the symmetric property of equality. Okay, let's go ahead, and here's the list of all of them. I don't have any room on your notes to write them all down, and I really think you know them all, so I don't think it's really necessary that we do that. You can see that on the notes, I'm going to want you to solve an equation with reasons example. I'm doing several examples, so you pick one eventually, and you write down all the steps and all the reasons like I did. And the rest of the vocabulary is reflexive, symmetric, and transitive. Okay, let's take a look at this problem, and we're going to do something similar to what I just did. You're going to solve for x, and you're going to tell me what each step is. So stop the screencast, try it on your own, and then look at the way I did it. Okay, here's how I did it. I went ahead and I wrote the first line, which is given, and then my first step was to add 4x to both sides, which is addition property of equality. Of course, you know there are other ways to do this problem. Then my next line was simplify. My next line was subtracting 2 on both sides. Next line was simplify. Then I used division on both sides, and then I simplified. Okay, the distributive property. Again, remember it's where multiplication over addition. And you can actually multiply over subtraction as well, so keep that in mind when you're doing the distributive property. Okay, here's another opportunity for you to do a problem. Stop the screencast, see if you can do the problem, and then look at my answer. Okay, here's my answer. I first write out the step, the problem it's given. I then use the distributive property. I want to get rid of the subtracting that's going on, so I add 40 to both sides. That's the addition property of equality. I simplify, I then divide, and then I simplify again. Okay, here are 3 vocabulary words, and I have what you should do on your notes is you should put this right next to the reflexive property, and this right next to the symmetric property, and this right next to the transitive property. And let's take a look at what they look like. Reflexive property looks like when something is equal to itself. Now I've also given you some place to write examples. So this would be a good example of when you're using segments. And this would be a good example of when you're using angles. And I always think of it as when something is equal to itself. Now the symmetric property is when you change the order. So if A is equal to B, then B is equal to A. Now this would be the example if you're using segment lengths. You just change the order that they're equal. Or here's an example when you're using angles. You just change their order. Now the transitive property is very interesting. It looks like a chain of reasoning. If A is equal to B and B is equal to A, now look at this connection between these two things that are equal and these two things are equal. And if there's this chain, this connection, then we can say the first is equal to the last. And this would be an example using segments. Notice the connection so that we can go from the first to the last. And over here, again, this connection right here, and we can go from the first to the last, and that's the transitive property. Okay, let's take a look at this problem. And they said, can we determine whether DBA is equal to EBC? So I've kind of started it off a little bit, and then we're going to continue together. Okay, so we are given this, because I can see a little tick mark here and a little tick mark here, so I know these are equal to each other. I also know that angle 1 plus angle 2 is equal to this big angle, and that is the segment addition postulate. And then I can see that angle 3 and angle 2 equal DBA, and that's also the segment addition postulate. Now I know that this is the same thing as angle 1, so I'm going to say the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle DBA. And that's called substitution. All right, so now I have two things that equal this. So this and this, and measure of angle 1 plus measure of angle 2, they're exactly the same. So these two are the same. So that means these two are the same. So now I can say the measure of angle DBA is equal to the measure of angle EBC. And notice the chain here. So you can say the transitive property of equality. Now some of you also might want to use substitution, and that would be okay as well, because these two, this can be substituted for that. Okay, so I want you to name the property that you're seeing. Stop the screencast, see if you can figure it out, and then start it up again. Okay, here are the answers. Number 7 is symmetric. Remember, we're changing the order. Number 8 is reflexive, when something is equal to itself. And number 9 is the transitive. Again, you have that connection, and once you have that connection, you know that the first is equal to the last, and that's what we're saying right here. Okay, go ahead and stop the screencast, see if you can do it again. You get a second chance. Now here are the answers. Notice that I recognize that number 10 is a transitive property with the connection. And again, the first will equal the last, which is what I'm saying right here. The order is changing, so that's a symmetric. And the last one, when something is equal to itself, that's a reflexive. Okay, here's our last slide. State the property of equality each statement illustrates. Okay, so I see A, B, and C, D. And what I see is something's being added to both sides. So this is the addition property of equality. Okay, I see two things that are equal, and there's a connection right here. So we know that we can go from the first to the last like this, and that's going to be the transitive property of equality. In this one, we're changing order, and that's going to be symmetric property of equality. And this ends the screencast.